Hi there, it's Sasha here from Coding Rooms, and I'm joined by Geraint Jenkins from the Bournside School. Could you introduce yourself?
Yeah, hi. I'm Geraint Jenkins, and I'm a computer science teacher for Key Stage 3 and Key Stage 4, and also Key Stage 5. So that's the GCSE age and the A level age. And I've been teaching now for 3 years. I've got a master's in computer science, and yeah, it's great. I enjoy it. It's good.
Awesome. Thanks for introducing yourself and joining us today. So, you mentioned a lot of words that some of our US-based users might not be super familiar with, and I know I myself am not entirely familiar with all of them. And it's actually one of our main topics for discussion today, which is GCSE standards in computer science and how Coding Rooms is helping um, teachers in the UK align their instruction again with Coding Rooms to those standards. And that'll kind of be the bulk of our discussion. But before we get into that, as always, I'm going to start with our product updates. So we shipped a huge feature for teachers who are using our auto grading and assignments functionality. Now you can have in one page a full overview gradebook with all your assignments and all your students. Then you can drill down either by assignment or by student. And that'll be supplemented with some really powerful feedback functionality also for those assignments coming next week. And you'll notice the ability to set different states for student submissions so you can pass back assignments, as well as the ability to add code comments in using the highlight and add a comment functionality that previously was not available for assignments will now be there. You can also record the video conferences that you do through Coding Rooms directly on your computer and download them. That's available as of today. Our version 2 IDE is currently in a closed beta. So if you'd like to be part of that program, please reach out to us, hello@codingrooms.com. We also pushed a new setting to Coding Rooms that will cause students' cursors to blur out of the way after a few seconds of inactivity. So that way you can see all the code, even the code that's directly surrounding the user's cursor, which previously would have could potentially block a little bit of code. We're also continuing to ship and update our pre-built assignments that we released a few weeks ago. So that's what you can expect in the pipeline and what's new on Coding Rooms. And without further ado, I'd like to jump into GCSE standards. So Geraint, if you could give us just a quick introduction to what GCSE is and specifically what GCSE computer science standards look like.
Okay, so the age for GCSE, we will call it year 10 to year 11, it's just the 2 years, which is ages 15 to 16. The GCSE course is split up into three areas. We call them components. So component one is the computer system part, where students will look at theory like CPU unit, the computer memory, storage, wireless networks, network topology, system security, and a range of other theory topics on theory of computers. Then the component two is computational thinking and algorithms and programming. This is where students would be using programming to develop these skills: computational thinking, creating algorithms, programming. And also there's a third area for GCSE, and that's called the programming project. Every student has to do 20 hours of programming, which has to be in a classroom environment, and teachers then have to monitor the students' progress and in a way notify the exam board that the student has done 20 hours of programming. That doesn't get graded, but it's a requirement. So students have to do the 20 hours. It used to get graded, but they've changed that for this year. And I think they will change it again going into next year. But that's an overview of the GCSE course. Yeah.
I see. And what programming language primarily do you use to teach?
We use Python. Um, you could use other languages, but my experience going like through other schools is that everyone uses Python. That's kind of like the standard. It's not a must, but that's kind of the one that most teachers I know use here in England. So yeah,
I
I
see.
think I think like maybe in the future I might try to move to other languages, but right now that's what we use.
And how
And
long have?
Python, sorry,
Yeah,
sorry.
go ahead. No,
I
there's
think
some.
Python's a really good um, programming language for
Mhm.
teaching. It's really good at, yeah, and the students understand it a lot easier than other languages. So it's a great foundation for them.
I see. I see. Yeah, I was just about to ask, how do you feel about teaching with Python, and how long have you actually been teaching with Python?
So I've been teaching now for 2 years with Python, um, and yeah, I like I said, I'm maybe this is more of a personal preference than a need. I prefer teaching with Python right now.
I see.
And there's a lot of resources for Python, teacher resources, because like majority of teachers I know use Python. So, and we all share resources. And um, so I kind of guess as you go through teacher training, and if you are taught using Python, then when you go into teaching, it's kind of natural to stick with what you were taught. It sometimes becomes a little bit scary to try a different language if you're not that confident with it. So that's where we are right now with my school, is that we use Python, but we can use other languages.
And what are some of those other languages that teachers might be using for GCSE?
I guess they could use JavaScript, C++, C Sharp. They are the ones that I would go into maybe in the future when I gather a few more resources, teaching resources for those um, programming languages. So yeah, they're the ones I think would be the ones I would go into. I don't know any teacher right now who uses any of those at GCSE level.
Mhm.
Uh,
Python is very forward thinking, because actually I was trying to kind of, I was educated in the American sort of AP system, and when I was in high school, I took the AP Computer Science A exam, which was in Java, and we did a lot of that stuff like algorithms for the most part, but it was fairly programming heavy, which is actually kind of surprising, especially for high school. And it sounds like GCSE um, has a lot more of that um, computer science theory in it. And from what I understand about AP Computer Science principles, maybe that's kind of the closest comparison I could draw. Which also, I believe you can choose the language, and there's a lot of different kind of computational thinking, vocal points, and how computers work. These kinds of topics I think are really exciting. Um, Now, we know a little bit about what GCSE computer science entails. Um, can you tell us a little bit how you're using coding rooms and how you're aligning your teaching, using coding rooms to those standards, to the GCSE standards?
okay, so um, we had a problem when COVID hit, where we were teaching from home, and this was a big problem because students have to do their 20 hours of programming. How are we going to do this? Because one of the requirements is that it's done in a classroom environment. Students are not allowed to do it independently; they have to do it within the classroom with the teacher there. So coding rooms right now is a great tool for us to achieve this, because we can um, have that classroom environment online. Students can program with us there. Really, we can see what they are typing. This is a great feature for us. So we can monitor their progress. We can track the hours they're pulling in. We can even see if there's a student who's really struggling with this project, and we can suggest that, give them some resources. We're not allowed to do the program for them, but it's good to identify those who do need help, and to then, send them to some resources that may help them with their project. But that's what we're using coding rooms for now, to help us achieve students programming at home, and also the giving them assignments. Like, we've always had programming assignments that students complete, like tasks, challenges. And coding rooms has a great feature, a built-in assignment feature, where students, I as a teacher can put the assignments up. Students can go and try this assignment out. It gets automatically graded for them. You mentioned earlier on about the new features coming out with feedback, and that's great. So teachers now can give feedback, and that's a real important principle that teachers need to do, is give feedback to students. So yeah.
See, and actually, outside of the podcast, we talked a little bit about these within the GCSE computer science framework. These topics and focus areas like student feedback. I mean, you mentioned that was a really important theme for you as an instructor, and that you're actually kind of assessed on some of those things, like providing student feedback and modeling solutions. Can you tell us a little bit more about those?
Yeah, so every teacher has, we have standards, things that we call them teacher standards. And as a teacher, we have to, constantly reflect on our teaching practice to make sure that we are achieving all these standards. So, for example, and how I link this in with coding rooms, which is why I think coding rooms is great right now, because it's helping me keep my teacher standards from home, because we've all been trained how to teach in the classroom and how to keep these standards, but no one's had training how to teach from home and keep these standards. So, like, for example, there's a teacher standard 6, which is give students regular feedback. How some teachers at home, there's lots of other ways you can be creative in giving feedback, by using lots of different apps, and even sending an email, but it takes a lot of time, and it's for teachers to use all these different applications. It gets really hard, because you have to memorize all these different apps you're using, and to check this one and that one. Anyway, so coding rooms with the feedback feature, I can achieve my teacher standard 6 by students completing the assignments, getting sometimes instant feedback, because we can set up auto grading, and that's instant feedback. So the student knows straight away if they've managed to complete that task correctly. So that's instant feedback. And then as a teacher, then I can have an overview of my class and see, oh, actually, like, those 10 have completed these assignments, and there's 2 students that haven't even attempted them. Then I can target those students, and that's within teacher standard 6. So it states that teachers need to use relevant data to monitor progress. Well, coding rooms has got that built in. It's got a data, it's given to us visually. We can see the students' progress. So that's another example of how coding rooms right now helps me to achieve that standard. And also there's a standard like teacher standard 1, set goals that stretch and challenge all pupils. So the way I'm using that right now is that on the assignments part of the coding rooms, I can set tasks that stretch and challenge the pupils. So right now I've got like we call them like difficulty levels. So level 1, and they try this, and as the more advanced students then can go, and it's there for them. They can, they don't need to do these, if they complete the easy tasks, then there's other tasks that's really stretch them. And that's really important in teaching, is you have you have things that really stretch the students, and you give them scaffolding. So, we need to be able to, if a student is struggling, to give them scaffolding. And using Coding Room's IDE, we can, in the assignment part, we can give them some scaffolding there and say, hey, if you need help on this, go here, click this link. If you need help on this, then, go and look at this, and we can kind of guide them on that. So there's a few examples there, but every teacher needs to look at these teacher standards and reflect on how they are doing. That's really important.
I see. In your experience with coding rooms, I know you started using it relatively recently, but what was it like for you to onboard students into coding rooms? How long did it take? What strategies did you use to get everyone familiarized and set up with the platform and run your first class?
That's a good question. So I created a manual for the students. It was just a PDF, and I demoed the system for them. So I said, hey, when you click this is what's going to happen. And I showed them, and I said, you need to do this. And I kind of give them the step-by-step progress, what they need to do. And yeah, it was fairly simple. So they, it's not difficult. They clicked the link, they signed up using an email. I would just use the school email address and set the password. And that's it, really. They were on, and because they clicked the link I gave to them, instantly they are part of my course, and so everything I have on there they can see. So it was fairly straightforward. I did make this little guide for them, like I said, like a manual in case they do need a bit of help on a few things. And on my manual, I talked them through, well, if they click on this is what will happen. And so, yeah, it was successful. And yeah, we still are going through that stage right now, because we've our next lesson, we'll see how they got on. But I'm fairly confident they'll be fine.
I see. Yeah. So and how many classes do you teach?
So right now I've got 2 A-level classes, and then Key Stage 3 classes. I've got, I think it's eight classes. And on the GCSE side, then it's a collaboration for 2 classes. So right now I'm mainly used for A-level because of the theory needed there is a lot higher than GCSE. But yeah, so every year it probably changed. So last year I was focused more on GCSE. This year I'm focusing more on A-level. But I still have an input into GCSE.
Oh, I see. And so what's actually the difference between A-levels computer science and GCSE computer science?
So as far as the kind of overview of A-level, it's kind of similar, really. You've got the different components. You've got the computer systems component. You've got the computational thinking and algorithms and programming component, and they both have 2 exams attached to them. So at the end of the A-level, the students would have 2 exams to sit. And then they have a major programming project. Now in GCSE, the programming project didn't get graded, but in A-level, it does get graded. And the students, again, can pick their own project, their own programming language. So right now, like last week, I set my year 12s up on coding rooms so that they can explore different programming languages, because they've been through GCSE with Python. Now I need them to have experience with other languages. So I've sent them to coding rooms, and I've got a couple of them doing JavaScript on there. Some of them have still sticking to Python because they're a little bit nervous to jump to other languages. But I really need them to try out other languages. It's really important for them, especially as they go on to university. And And that's, I don't know how it works in America, but here, like they go GCSE, A level, straight into university.
And from A levels computer science, I mean, you may or may not have data on this, but what, if you had to estimate, what % of students end up pursuing computer science in university?
Oh, it's a good question. My current year 13, so they're a year away from university, and I was a bit disappointed this year because I've only got a few of them who's going to go into computer science, which I was shocked about. I was like, why? Like, you, and actually some of them are like high end students. So I'm trying to like persuade them, obviously I can't tell them what to do, but I'm trying to make the subject fun for them and, kind of show them the potential that computer science has for them as a career. My current year 12s, I'm pretty sure they'll all pursue it. So I haven't got data on it, and I don't know if that answer has helped, but that's where I'm at this year, is that only a few of them are going to pursue it.
I see.
So, yeah. So hopefully that changes.
Yeah. I think one thing that's interesting for me is I wonder maybe what % of them think that they already learned a lot about computer science and want to like explore something else, but still take a CS job or CS related job, because a lot of jobs now, you may not need the sort of rubber stamp of a CS degree if you have hands-on programming experience that it sounds like you're getting a lot of already in high school.
Yeah, I love the subject computer science, and I think even if they don't pursue it as a career, like the skills they learn from studying computer science is, they learn so much stuff. Like even the ability to problem solve, like that's a skill that can be used in other areas, in other subjects, in other careers. Algorithms are not just sitting down creating a program. You could learning that skill of creating an algorithm can again be used in other careers, because again, creating an algorithm is just problem solving, thinking about something you need to achieve and coming up with a set of instructions to achieve it. So I really hope, even if they go to different careers, that it's been extremely beneficial for them to do the subject.
I think that's almost guaranteed. I think, especially with the utility of a language like Python, just for data in general, right? Instead of Excel wrangling skills, you can do the same in Python and be more efficient for certain things, for sure.
Yeah, definitely. Yeah. So I just really hope that they do go away and pursue something to do with computer science. It is the best subject out there, surely.
Yeah, I think
Sorry
we all
if
agree.
teachers are listening for other subjects, because every teacher would say the same thing. But yeah, I love computer science, and it's really important, especially these days. Like, it's needed. There's a shortage of programmers, so.
Yeah, definitely. I think that, definitely our audience is almost exclusively programming teachers and students. So I think all of us tend to agree with that viewpoint. Although it is interesting to sort of take the opposite side, but I don't know. I'm struggling for sort of rational arguments on that, at least in a meaningful way. So I wonder, now you've done a little bit of teaching with coding rooms towards these GCSE, and it sounds like a little bit of the A-level standards. Can you describe a little bit how your teaching workflow has changed? And maybe we can talk about these three or four elements even, which is like pre-COVID, and then COVID before coding rooms, COVID after or with coding rooms, and then kind of a future forward-looking no COVID with coding rooms.
Yeah, okay. So again, this is going to be probably different to every teacher that's listening to this, because every teacher does it differently. For me, then, if we look at before COVID, pre-COVID, so um, in the classroom environment, we would set the students these challenges, programming challenges, and they would then complete them on idle, so just on the computer. And then as a teacher, I would have to walk around the classroom and check that they're all okay, and you know, and that would kind of be most of my lesson, really, just walking around to check in that all the students are okay and fine. And then when COVID hit, we weren't really prepared for teaching at home. Like, surely not many people were. So we needed a way of getting doing the same things that we were doing in the classroom, because we can't just drop programming and then just end up doing lessons on Zoom and doing lectures in a way, because we need to keep up what we were doing in the classroom, otherwise they're going to fall behind. We had just before COVID, we were using some other programs, online platforms, to kind of transition the students from idle. I wasn't a big fan of idle. I kind of thought it'd be good if it was something a bit easier for teachers. Anyway, and then COVID hit, and then I came across coding rooms, and everything that I needed to, track pupil progress, to be able to give feedback, to give them assignments, to be able to see them like virtually, then coding rooms did all that for us. So that's why we are using coding rooms now. But then looking forward, some teachers may think that all of these skills and tools that we are using now may then become obsolete in the future. Like, do we really need these things in the future? But um, I think that we do, because even in a classroom environment, using coding rooms, and I'm going to be using it when we're back in the classroom, because if you think back before, I would have to walk around to check every student's computer screen, and see how they're doing. I'd be tired after a lesson walking around, and also we have a problem where students don't like to speak up if they're struggling. Like, it's scary for them. So, having a way of seeing if a student is struggling without making it obvious to the rest of the class, I think that's quite powerful. So like, looking forward, then I can see this situation where they would come into the classroom, we'd have coding rooms. I would give them small steps of theory, and then I would set them a task on coding rooms, and I would monitor their progress using the IDE that coding rooms offers, and I could see then all the students programming live. And then that means then I don't really have to go around to every station in the classroom. I can just see it on my screen. That's I'm not saying that to be lazy. It's just, it just helps then the teacher to be able to see live the students' progress, because even when you walk around the classroom, you end up going behind a student, and they know you come in, and even if they're struggling, they can sense the teacher's coming in, and they'll just, they'll start typing again. And you kind of miss that. You think, oh, they're fine, Johnny's fine or Sue's fine, and you just move on because they're coding. So in a way, then, what I'm saying is that in the future, even using these online IDEs and is going to be beneficial for the classroom for these situations. Even modeling is extremely important for teachers. Students need to be able to see an example. So you give them a task, and then as a teacher you model it. well, you could do that so they can, instead of them all facing around and looking at the board, they can then look at their screens and see me modeling it, and it's on their screen. And I think that even that's great. I've been in a classroom, and I don't like staring at the board. Turn this way to the board, and then having to do this. Like, I've seen this happen in a few classrooms. And the teacher puts some code up on the board and say, right, kids, students, can you type this out? And then all of a sudden, they're like this, and they try to then copy the board, and like, that's surely from the 1980s. Like, we're 2021 now. So with coding rooms, we can model an example and say, hey, it's on your screens. You can literally now use my code that I've typed and, expand on that and stretch them. Then you can give them scaffold, and all these things are really important. So, if I've modeled it, they can use my code on the IDE, and then if I can see then that they're struggling, I can then anonymously, without the other students noticing, I can then send that student a little bit of help, and I can maybe complete their code for them. I can even see if they haven't done anything for 5 minutes. That's great. And maybe I'll walk over there then. If someone has done it for 5 minutes, I'll walk over and be, are you okay? But it's having that data there in front of you. It's live, and just in a way, just being clever with the tools that are available to us, and changing our ways. Really, teachers need to change their ways just to keep up, and it does help them with teacher workload, and that's also an important part of using things like coding rooms, is because these systems are there, these apps are there to help teachers with their workload. We don't have to reinvent the wheel here. We just have to use these apps and these features to help us achieve what we need to achieve, help the students progress, all from one app. So that's good.
Awesome. You mentioned a lot about teacher workload. Can you describe a little bit what your grading workload was before coding rooms, and how coding rooms is helping with grading?
Okay, so that's a good question. So I guess, like, before coding rooms, you'd set the task. Let's say you had 10 programming tasks, and then you'd have to then look at all the code for every student. You'd have to mark it. You just give them feedback. You'd have to then log it on your system, because you need to keep data. It's a teacher standard. You have to keep data to be able to monitor that pupil's progress. So then you'd end up using Excel, and you put in all this data, and so it would. And so anyway, I think using coding rooms then, that does help with the workload, because you can put the effort in before, and you can. So anyway, you set up the challenge, the task, the question. You can give them some help on that question as well. You can set them. You can scaffold. You can even give them the start of the program, so you can set that up for them. So it gives them a bit of a hint. That's great. And then you can then grade it. So you can set up these tests. So you can say, well, if it's looking for this input and that input, it should have this output, and it does the grading. So if I was to put the effort into setting that up for one class, then I can use all of that for all of my classes. So, I've reduced my workload now. I've put the effort in before. It might take me a bit of time. It took me, I set up six quite good challenges on coding rooms, and it took me about 40 minutes, and I was with some grading practice in there, and some other things. But saying that, then you guys came out and gave me a load of resources, and like, what more could a teacher want? So, I would spend, so even now you've reduced my workload because, now I've got, I can't remember how many, the amount of practices you've given me, but I think it'll last them for a good year. And it's got the grading in there. It's got everything in there. So yeah, that's another great way that this has helped me with my workload. So I was spending time setting these things up, and then all of a sudden you guys came along and said, hey, look at these. And you've even planning to do JavaScript, I think. Is that right?
Yeah, JavaScript is on deck.
Yeah, and and I've told my year 12s, I said, JavaScript is coming. I'm going to give you some challenges on there to help them develop. So yeah, so it definitely is helping with teacher workload and being smart with it. Again, like I said, this isn't about being lazy because teachers aren't lazy. You just have to be smart, and if something's available to us, then we use it, and we use it to help the students to progress. So win-win.
I see. Yeah, I guess you could kind of imagine it as there's and feel free to provide your input on this, but the way I see it is there's like a certain benchmark standard that every teacher, every classroom kind of has to hit, right? And that's kind of a passing benchmark, right? But then after that, there is kind of this idea of, roughly speaking, unlimited improvement potential, right? Because there's kind of no real limit on students' knowledge or sort of like, say, maybe total knowledge scope when they exit a class, right? So every time you make the class more efficient, it's kind of ought to be a net gain, right? And so when you mention things like saving time on grading, but then you talk about adding more labs, more practice. Students can go through the feedback cycle quicker, and then they can actually focus on learning even more than they otherwise would. And I guess that's kind of it's what I've been hearing a lot from our users, and it's something I'm really excited about because I hope that this can help like the wide variety of students that come into computer science. I don't know actually if you have this issue with GCSE quite as much, but I know it's a really big problem, like especially with APCSA in the US, is that you'll have tons of students who never took any intro course and really know nothing, kind of starting from zero. Meanwhile, you have students who could probably write the AP exam tomorrow if they had to. And you just have your only kind of like benchmark, right, of success is that everyone more or less passes, right? But that's such a huge wasted effort in a way, right? If you kind of look at things at the end of the year. So it's really exciting to hear that we're able to help in this regard too, not just in meeting the pass bar.
I've actually got quite an experience with that this year. So I've got a year 12 student who has never done computer science before. Never. So they were from different school and they did not do GCSE computer science. So, but now they want to do A-level. So we accepted them because we did give them like a little bit of a test before to see, if they could achieve this. And he was very keen, and from his the questions we asked him, like he showed the potential. Anyway, so I have a problem now because I can't really, if I was to teach programming, I've got a wide range of students there. If I can't just go jump straight into doing classes and because this student doesn't even know what class is, and it's not his fault. Like he should be there, and I'm glad he's in the lesson with us, and I really hope that he pursues computer science and he sticks at it. But now, so if to fix this problem, I need to provide the students with different ability levels. So on our assignments that we set, I know some people hate the Hello World program, and I've heard some people say that you shouldn't use it for the beginner programming, but it's something
it's new to me. I haven't heard that argument, but okay.
Yeah, no, I remember reading once that I was in I can't remember what magazine it was, like a computer science magazine that said, "Hello World is the worst program you can teach a student." Anyway, that's another topic. But this student can go and try the smaller, simpler tasks, um, and then these students can go jump right up to the the harder tasks, and then I can help them both achieve it because they have they can use the IDE to do those different things rather than me then just trying to do the resources for this student to try to help him and then resources over here to help these guys. And in a way you end up being a circus act in the classroom. You just need the resources there, and you can then help this student on their level, and then these guys on their level. But yeah, so that's I think the range of assignments and the independence that the students can have then with the scaffolding from me is great. It's important.
Interesting. I while we were talking earlier, I kind of I was thinking a little bit about your formal CS background because in a way it is unique, right, for a K-12 CS educator to actually have like a postgraduate education in computer science. And I don't know how many of your colleagues share that. Maybe it's at your school or.
Yeah, I I don't know. I don't know. I think like it's not you don't hear of many teachers with a master's in the subject that they teach, especially in computer science, because those who have a master's usually end up not doing teaching and they end up going off and doing something else. But yeah, I haven't met a teacher that does have a master's, but that doesn't mean there aren't lots of us. And it does help me. It does help me teach the subject. And I'm passionate about CS, and so having the knowledge and having the masters, it does help me be very creative with the resources and helping the students understand it.
Yeah, that
But
was really interesting.
I don't want to say that if teachers don't have a master's, then they're not as creative, because that's wrong. That's wrong for me to say that, because there are teachers out there who don't have a CS degree, who maybe have another degree, who do teach computer science, and they are great as well. It just helps me. I do feel as if the knowledge I have does help me teach.
I see. Yeah, that's exactly what I was kind of getting at. Is like, I just wonder, kind of how you found that, if that's a common thing, and I guess if you have anything that you'd like to kind of, or I don't know if you have maybe recommendations that you've seen from your perspective of things or maybe resources that would be useful for teachers who have less of a formal CS education background or work experience, that could be useful for them. I think that's a really interesting. That's probably its own podcast altogether. But what are there any big things that come to mind for you?
So as far as resources go,
Yeah, and themes, I guess, just bigger picture items.
There's great resources out there for CS teachers that the teachers can go and use. They can be quite expensive. That's the only problem. So like we bought for our school, we bought resources in last year, which gives the teachers all the PowerPoints and it was really expensive. I don't know how much resources are in America, but it felt expensive to me. You're talking about over £1,000. I think that's a lot for PowerPoints. But so yeah, there are resources out there for teachers. I don't know if I can like name any on this podcast, or is that allowed?
Yeah, for sure. Yeah, we talk a lot about other resources, and Um, also, I guess, just anything that helps teachers.
Yeah. So, well, the way I do things right now for resources, I do love creating my own resources. I find it fun because I like thinking about how the students think and to help them. So, um, I always look at a range of resources. So, we bought these resources in last year, no, this year, 2020, from PG Online. That was and then, they gave then quite loads of PowerPoints. Every topic was covered in there. It did lack it. Well, no, it did. It does lack a few little bits in there, and I kind of think that they could have like covered this area as well. So you can't fully rely on just one resource. So then we also use Craig and Dave. Again, if anyone's in England, CS teachers, they may have already heard of Craig and Dave. And they provide, again, loads of resources and PowerPoints and starter activities. And I've been using that since I've been teaching, and it's great material. But then I always then end up doing my own in the middle, and I use Craig and Dave stuff, and I use PG Online stuff, and sometimes I mash them up and kind of then create my own resource to put my own spin on things. But yeah, so like, this week now, I had to teach my Key Stage 3 students problem solving. So I just went and used just did a Google search on TESS. That's another website, TES. Most teachers would know of TESS, and they have resources on there. And I just found some starter activities, and then I used it, and I implemented it in my lesson within my own resources. And then, yeah, so that's how I do things right now. Every teacher will do things differently, but yeah, that's what I do.
I see. And so I guess you haven't used a traditional textbook ever in a high school CS class, or not recently.
Now you've asked that, I haven't actually. I've never really used a textbook. We give the students a textbook, but I don't like say I don't teach with it. I don't say, right, turn to this page and look at this. Everything is digital for us. So the textbooks are there more for their independent study and to help them then with, scaffolding in a way. So if they don't understand the topic, they can then go look in the textbook. So it's not that I don't like the textbooks. I just never have really used one. Like I've never had one up the front of the class, apart from showing them, like, this is a textbook we're giving you, and that's it really.
I see.
Maybe I'm wrong. Maybe I should use it more. Wonder what other teachers are doing. But yeah.
Yeah, that'd be interesting to know. Do you use a lot of video content too, or is it mainly the written exercises?
Yeah. So actually, we do a lot of flipped learning, and we set the students homework where they have to go and watch a video. They're only small videos because students can't concentrate on a video for more than 6 minutes. I think the stats are. After 6 minutes, you lose them. So we try to, like, videos usually are in that time frame, and it introduces the topic. And then what the students will end up doing then is they come prepared for the lesson, and that then saves the teacher then going over the material, and then it gives us the time then to help the students with the collaboration, and to help them the worksheets and the resources, and to then put the information that they learned from the video and use that knowledge then in like an exam question, and to help them with with the worksheets that we have. That's how we do things right now. It's called flip learning. Again, there's a lot of different research on flip learning. About some research says it's good, other research says it's not. I'm a strong believer in it, that I think that students do like watching YouTube, they do like watching videos, so why not give them a 5-minute video where there's, introducing a new topic, and then, so they just come prepared. Yeah.
I see. That's awesome. That's awesome. Is there anything else you'd like to mention about coding rooms, about the A levels, GCSE, anything else, parting words?
No, I just would encourage teachers to check it out, because it's a great tool. It's working for us, and I know it's working for other schools and other teachers. So I would say to check it out and to look into using it, and to, in a way, change. Sometimes we, as teachers, we do need to change our mindset and to think of other ways of teaching. Again, that comes back to teacher standards. We always need to reflect on: are we doing it the best way? Are we doing it? Are we being effective? And just to reflect on those questions, and then, is everyone can improve. I can improve. Every teacher out there can improve. No one's perfect. So how do we improve? What tools are available for us to improve? How can we help our students improve? So yeah, just check it out really, and see how you can use it.
Awesome. Thank you for sharing your experience with coding rooms and how you're using it in the GCSE and A levels standards. Great.
Yeah,
Awesome.
Thank you. Thanks for having me.
Thank you. Awesome. That's it for today's Coding Rooms podcast, and we hope to see you again next week. Thanks. Bye.